Have you ever been driving over a massive bridge or seeing a picture of an oil rig way out in the ocean and just stopped and thought, how? How on earth do you build something that huge, that solid, when your entire construction site is just water? Well, we're going to get into that because the engineering that goes on beneath the waves is absolutely mind blowing. In this quote right here, this just perfectly sums up the first, almost magical sounding problem you have to solve. Before you can even think about building up, you somehow have to push the ocean out of your way. So, yeah, how do you do that? How do you create a safe, dry little pocket of land when you're completely surrounded by water? You know what you do? You build a fortress. It's a temporary one, sure, but it's a fortress all the same.
It's called a cofferdam, and what it is basically a giant temporary wall. Engineers drive these massive, interlocking steel sheets deep, deep into the seabed until they form a perfect seal. Once that wall is up, they just pump all the water out from the inside, and boom, just like that, you've got a dry workspace at the bottom of the ocean.
But you gotta understand, this is an incredibly risky setup. You have the crushing force of the entire ocean pushing in on those walls. We're talking unbelievable pressure. A single tiny crack, one little bad weld, and that water will come bursting through with violent force. The whole thing could flood in seconds. The stakes are just ridiculously high. Okay, so the cofferdam gets us our dry land. That works. But the old way of building the foundation inside was still really complex and slow. You'd have to drive a bunch of smaller piles into the ground and then build this big concrete cap to connect them all. It's a lot of work. So naturally, engineers started asking, right, this works, but is there a smarter way, a faster way? And the answer, it turns out, was a huge, resounding yes. It led to a total evolution in how we think about these foundations, one that's all about simplicity and massive strength. Enter the monopile. And you can see the difference immediately. I mean, just look at this. On the left, that's the old way. A whole group of piles that need that giant concrete cap to hold them together. And on the right, the monopile. Just one single, massive steel pile that does the job of all of them combined. It's just so much cleaner, so much more elegant. And here's the kicker. This isn't just about looking better. The advantages are huge. It is way faster to build, it costs less, and maybe most importantly, it's so much better for the marine ecosystem. You're doing way less drilling, there are fewer barges going back and forth burning fuel. I mean, it is a win-win-win. And let's put some numbers to that. Look at this! Building one of those old group pile foundations takes on average about 20 days. A monopile, you're done in about 7. That's a nearly 60% time savings on every single foundation. Now imagine a bridge with 100 of those. The time you save is just astronomical.
And to really put a fine point on it, check out the Mumbai Coastal Road project. By making the switch to monopiles, they eliminated the need for 566 individual piles. 566, that's not a typo. Just think about the materials, the money, the time, and the environmental impact saved. It's truly staggering.
All right, so we've built our foundation. It was fast, it was efficient, the structure is up. But the job is far from over. Now a totally new battle begins. It's a fight against an unseen, unstoppable enemy that never, ever sleeps: corrosion. That salty seawater is constantly trying to eat away the steel that's holding the whole thing up. And this is what that enemy looks like. On the left, that's what happens to unprotected steel in the ocean. It's just getting eaten alive. On the right, well, that's the dream, isn't it? A perfectly clean surface, totally protected from the ocean. The question is, how do you get there? I mean, that really is the multi-billion-dollar question, right? You can't just slap a coat of paint on it and call it a day. The ocean will tear that apart. You need something active, something that's going to last for decades, maybe even a century, without needing a ton of maintenance. And the solution? You're not going to believe this. It's something straight out of science fiction. We're talking about, essentially, an electric shield. It's a technology that literally uses the sea's own chemistry against itself to build a suit of armor around the steel. So how does this electric shield actually work? Well, this system, called ECOS, passes a very small, low-voltage current through the steel pile. Now, that little bit of electricity changes the water chemistry right at the surface of the steel. And it causes the natural minerals, calcium and magnesium, that are already floating around in the seawater to literally pull out of the water and stick to the pile, forming this hard, protective, almost rock-like skin. It's genius. It forces the ocean to build its own armor.
So, does it work? Oh, yeah, it works. Just look at this chart. Even with standard protection methods, you're still losing a little bit of steel to rust every single year. But with the electric shield, zero, zilch, nada. It brings the corrosion process to a dead stop.
And if you want to see the proof with your own eyes, check this out. These are actual metal plates that were left in the ocean. The bottom rows got either no protection or just the standard stuff, and they are a rusty mess. But that top row, protected by the electric shield, it looks practically brand new. The evidence is just undeniable. So the next time you drive across a bridge like this or see a wind turbine standing out in the waves, just remember all the invisible engineering that's making it possible. From those temporary fortresses that let us build on the ocean floor, to the elegant monopiles that do the heavy lifting, all the way to the electric shields that are fighting a constant, silent war against rust. And it kind of makes you wonder, doesn't it? As we try to build in even crazier and more difficult places, what other invisible forces are out there that we're going to have to understand and learn to master to build the world of tomorrow?